couple weeks ago while playing games, I came across this error. At the time, I assumed it was something to do with my graphics card, but upon further research, it seemed like there was an issue with Intel CPUs. Intel basically let motherboard manufacturers just push the power limits of these CPUs way past what they're supposed to be, and this has caused some major instability issues. I came across many different pieces of advice. Some of it was really good, and some of it was just incredibly wrong. So I'll run you through all of my findings, and at the end, I'll even give you a little bit of a tip to increase the performance of your CPU. But to give a quick disclaimer, I'm no expert when it comes to overclocking, as well as many of the complicated settings there are in the BIOS. I would exercise caution when following any of these steps. Do your own research, and your problem might be different than mine, so just keep that in mind. But I wanted one simple guide that had all the information that I came across. Now I have my CPU running cooler and no longer crashing across the wide variety of games I play. So if that's something you're interested in, you could definitely stick around. Now your first step is take a baseline score of where your computer currently sits. I'm using Cinebench R23 to get my scoreline. I did this test before I got any of my other scores. So for my first test, I reset the BIOS, turned on XMP for RAM, and then didn't touch anything else. This is how the processor runs from Intel with the motherboard's base included overclocked setting. The Cinebench score I got was 37,189, and to make sure that the crashes were still happening with these base settings, I ran the Intel AVX2 stress test and it failed, and I ran Dead by Daylight, which now that it's moved to Unreal Engine 5 has been experiencing crashes. It also crashed on Dead by Daylight. My next step was actually testing the Intel baseline profile. So I would recommend doing everything in the Intel Extreme Tuning utility first, and then once you've figured all your settings out, then going into your BIOS and changing something. For the Turbo Boost Short Power Max and the Turbo Boost Power Max, I set 253 watts for the 13900K. I would recommend making your processor core ICC max 307 amps. These settings are for the 13900K. I'm gonna put up a graphic on the screen that shows you the different power limits and what they're supposed to be based on Intel spec. Run a test like this, use hardware info to get some information on your temperatures, and do the Cinebench test as well as the AVX2 test. And if you can, find a game that you know crashes, like for me, which is Dead by Daylight. It crashes every time when you start up, so it's the perfect game to test with. See if you're having any issues at the base settings, not the extreme profile. If you're having issues on the base settings, it's most likely that your chip has gone bad from degradation over time, or the chip had some other issues in the first place. RMA is definitely your best option. That's basically everything you need to make sure your chip's running properly. The problem with this method is when we run Cinebench, we get a score of 34,776. It's about a 3,000 point drop in the Cinebench score. This might not really affect a lot of gaming performance, but it definitely affects your productivity performance. And if you bought one of these high-end Intel chips, you definitely don't want to be running at this spec, mainly because you paid the money for the little bit of extra power that you get with these Intel chips. Now, the next thing I would do is set your processor core ICC max to 400 amps, which is the Intel spec for the extreme profile. Do tests and see if you have any issues. When I run Cinebench, I have no problems. With the 400 amps, I get a 36,547, which is much closer to the original score, but it's still about 500 less. When I run with processor core ICC max at 400 amp, my games actually still do crash. The only solution I found to running it at the extreme profile is to change your load line calibration in the BIOS to level 4. From my understanding, this basically lowers the amount of voltage drop that your CPU experiences. This actually fixed my issue with the extreme profile, and then after this, it became flawless. My only issue was that the temperatures were still rising very high. When doing a Cinebench test, you'd still hit that 100-degree mark very frequently. After doing more research, I actually found out a different way, and I found a lot of people saying that undervolting your CPU can actually lower the temperatures. Now, the amount that you can undervolt each CPU is different based on the silicon that each chip has. The best way I figured out to test this for stability was to set the core voltage offset to -0.05 and then run the AVX2 stress test. If the voltage isn't stable, this stress test usually crashes within the first 30 seconds, so it gave me a really good idea of where I was going with this. And then I kept slowly decreasing this undervolt by 0.005 until I experienced AVX2 crashes. I've seen other people report almost a 0.1 volt drop when they were undervolting with no stability issues, but for my specific chip, I was only able to get a 0.02 undervolt. And now after running these settings on the Cinebench test, I was able to get 36,885. And when I ran these settings prior to resetting everything for this video, I was able to get a 37,192, which is actually 3 points better than the base Asus profile overclock that was applied to the CPU. I also noticed during the 10-minute Cinebench test that I wouldn't hit 100 degrees. I'd hover around 98 for the package. and about 95 to 97 for each core. So in this way, I was able to limit the CPU's power draw, increase stability, while getting near identical scores. Now finally, I'm going to show you what it looks like on the BIOS side. Each BIOS is going to be different. I've seen the BIOS for other motherboards and it does look a little confusing. So do exercise caution when you're looking around. But if you go into the advanced mode and then you go under AI tweaker, here we'll have all the settings relating to the CPU. I was recommended by many people to not change the SVID behavior. If you keep scrolling down, you want to look for internal CPU power management. Under CPU core cache current limit max, you want to set the 400 amps as before. For long duration package power limit, you want to set 253 watts. And for short duration package power limit, you also want to set 253 watts. Next, you want to head to Digi plus VRM. This is where I adjusted the CPU load line calibration. If you just wanted to run the 400 amps without undervolting, I recommended setting the load line calibration to level 4. And lastly, to set the undervolt, you want to go to global core SVID voltage. You want to make sure the offset mode sign is the minus so that it's an undervolt, not an overvolt, which could be dangerous. And then you want to set the offset voltage to 0.02. From my understanding, this offset voltage doesn't lower the voltage at all times. It only drops it a little bit when it's under high load. Once again, I'm not an expert, but this process did work for me. After this, you just want to save and exit your BIOS. So now these settings will apply every time you turn on your computer. Hopefully this method helps you with your CPU. It's incredibly frustrating that Intel hadn't thought of this issue when they were first creating their CPUs. It seems to be specifically with the AVX2 instruction set. So if they hadn't truly tested for stability with those things, it might be the reason why we're having all these issues now. And hopefully the guide was simple enough to follow.